with the continuation of the next sum in the inverse trigonometric concept. Okay, in question number 8 we'll prove 3 sine inverse x equal to sine inverse of 3x minus 4x cube. See, considering right hand side term and proving left hand side term will be very easy, because in the place of x if you substitute, that is sine theta, 3 sine theta minus 4 sine cube theta, it will become the expansion of sine 3 theta. So that aram se you people will be getting the result of left hand side after considering RHS. So you put right now x equal to sine theta, theta equal to sine inverse x. Okay, next you consider RHS. Okay, sine inverse of 3x minus 4x cube, this is equal to sine inverse of 3 sine theta minus 4 sine cube theta, it can be written as sine inverse of sine 3 theta. See, after looking the term 3x minus 4x cube, okay, we should come to know that after supplying the trigonometric functions, okay, it will be the expansion of sine 3 theta. Similarly one cos, okay, similarly for tan. Okay, like this many sums are there in the inverse trigonometric concept, so we have to see them even in details also. So in the last line, sine inverse and sine both are cancelled, so just 3 theta will be remaining. Theta in the sense what? Sine inverse x. So that here you people got left hand side result. This is the proof of this given problem. With the continuation of the further sums, in question number 9, we'll see to prove that 3 cos inverse x equal to cos inverse of 4x cube minus 3x. Okay. See, considering right hand side term and simplifying will be very easier than to get the left hand side result. So because after looking the term 4x cube minus 3x, if you supplied in the place of x one suitable trigonometric function, that is cos theta, so 4 cos cube theta minus 3 cos theta, it will become the expansion of cos 3 theta. So once you get cos inverse is already there, if you get cancel it, aram will be getting the result what we are required in the left hand side. So its simplifications will be very easy. Now you don't think, put one trigonometric function, that is x equal to cos theta in this problem. So theta equal to cos inverse x. Okay, you consider RHS, cos inverse of 4x cube minus 3x. Okay, next cos inverse of 4 cos cube theta minus 3 cos theta, it can be written as cos inverse of cos 3 theta. So cos inverse cos are both are cancelled here, so 3 theta will be remaining. 3. Next theta in the sense what? Cos inverse x, already you are written at the beginning. Okay, so you people have got right now left hand side result. Okay, so RHS is equal to LHS. So this is the result of this given problem. Next, in this question we'll prove that tan inverse of 1 by 2 plus tan inverse of 2 by 11 equal to tan inverse of 3 divided by 4. So when you'll be proving tan inverse of 3 by 4, here one standard property we have in the concept of inverse trigonometric function, that is tan inverse x plus tan inverse y equal to tan inverse of x plus y divided by 1 minus xy. So considering left hand side term, applying the property, so after simplifying this term, aram you will be getting the result, that is tan inverse of 3 divided by 4. So LHS equal to, you consider the given term as it is. After this you apply this property now. X in the sense 1 by 2, y in the sense 2 divided by 11. So it can be written as tan inverse of 1 by 2 plus 2 by 11 divided by 1 minus 1 by 2 into 2 divided by 11. So this is equal to tan inverse of 15 by 20. How it is 15 by 20? See, 11 ones are 11, 2 to the 4. 11 plus 4 is how much? 15 divided by 22 divided by 22 ones are 22 minus 2 is how much? 20. 20 divided by 22. So 22 from the numerator side and 22 from the denominator side, if you get cancelled, then just 15 by 20 will be remaining. So cancel the numerator as well as denominator terms. Okay, that is 5 3s are 5 4s are. So what the result you people required, that already you people have got right now. So tan inverse of 3 by 4 will be the RHS result of the given problem. Okay, so LH is equal to RHS. Next, in the question number 11, again we'll prove that tan inverse of 2 by 11 plus tan inverse of 7 by 24 equal to tan inverse of 1 by 2. Okay, whatever the procedure you will have been followed in the previous sum, the same procedure if you adopt here, so that you will be getting the result tan inverse 1 by 2. Now you consider LHS. Okay, next apply the property tan inverse x plus tan inverse y equal tan inverse of x plus y divided by 1 minus xy. X in the sense 2 by 11, y in the sense 7 divided by 24. In this property, you adopt the angles, okay, wherever x and y are there, okay, so that after simplifying, you will be getting what result you are required in the right hand side, that arams you can get it. So now tan inverse of 2 by 11 plus 7 by 24 divided by 1 minus 2 by 11 into 7 by 24. So this is equal to tan inverse of, you find the LCM of the numerator as well as denominator term. 24 into 2 is how much? 48. Next 11 into 7 is, it is 77 divided by 11 into 24 can be written as 264 divided by 264 into 1 is 264 minus 2 into 7 is how much? It is 14 divided by 11 into 24 in the sense it is 264. Okay, 264 and 264 from numerator and denominator terms both are gone. Just okay, tan inverse of 125 divided by 250 will be remaining. So 125 ones are 125 twos are 250. So you people have got right now right hand side result. Okay, this is the proof of this problem. In question 12, we'll prove that 2 tan inverse of 1 by 2 plus tan inverse 1 by 7 equal tan inverse of 13 1 divided by 17. Okay, see, just for time being, you consider 2 tan inverse 1 by 2 is equal to, okay, it can be written as tan inverse 1 by 2. How many number of times tan inverse 1 by 2 are there? 2 times. So it can be written as tan inverse 1 by 2 plus tan inverse 1 by 2. So apply the property, that is tan inverse x plus tan inverse y equal to tan inverse of x plus y divided by 1 minus xy. So now tan inverse of 1 by 2 plus 1 by 2 divided by 1 minus 1 by 2 into 1 by 2. So it can be written as, okay, tan inverse of 1 divided by, it is 1 minus 1 divided by 4. Numerator side 1, how it is? 2 ones are 2 ones are, okay, into 2 twos are 4. So 2 plus 2 are 4 in the numerator side, 2 into 2 are 4 in the denominator side. So 4 and 4, if you cancel it, just 1 will be getting in the purely numerator side, divided by 1 minus 1 divided by 4. Again find the LCM from the denominator side. 4 ones are 4 minus 1 is how much? 3. 3 divided by 4. Okay, tan inverse of 1 by 3 by 4, it can be written as tan inverse of 4 divided by 3. So the total result of 2 tan inverse 1 by 2 will be tan inverse of 4 divided by 3. Okay, next you back with the given original left hand side term, that is tan inverse of 4 by 3 plus tan inverse of 1 by 7. Again you apply the property tan inverse x plus tan inverse y equal to tan inverse of x plus y divided by 1 minus xy. So x in the sense 4 by 3 plus y in the sense what? It is 1 divided by 7. So it can be written as tan inverse of 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. Tan inverse. Okay, find the LCM. 7 into 4 is 28 plus 3 ones are 3 divided by 7 into 3 is how much? 21 divided by, again 7 into 3 21. 21 ones are 21 minus 4 ones are 4 divided by, it is 21. 21 and 21 both are gone. Okay, tan inverse of 31 divided by 17 is, okay, it will be remaining. Now this is equal to RHS. So now in question 13, okay, prove that cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse of 33 by 65. You consider LHS. Okay. Next, here you have a standard formula in the concept of inverse trigonometry, that is cos inverse x plus cos inverse y can be written as cos inverse of xy minus root of 1 minus x square into root of 1 minus y square. Okay. Next, x can be considered as 4 by 5, y can be considered as 12 by 13. So in the standard property of inverse trigonometry, what we have already showing you, in the place of x and y, if you substitute these angles and after simplifying the result, what you people are required in the right hand side. Okay, so now we'll see the simplification. So cos inverse of 4 by 5 into 12 by 13 minus square root of 1 minus, it is 4 by 5. After making the square to the respective angle, 4 square is 16, 5 square will be 25. Again square root of 1 minus. Okay, next y in the sense 12 by 13. 12 square is 144, 13 square is 1 divided by it is 69. Okay, now after simplifying this term, cos inverse of it is next 4 into 12 48, 5 into 3 it is 65 minus, find the LCM from the square root term. 25 ones are 25 minus 16 is how much? It is 9. Okay, 9 divided by 25. After taking it is out of the root, it will be 3 divided by 5. Okay, into find the LCM from the second square root term. 1 into 169 it is 169 minus 144, it will be 25 divided by 169. 25 after taking it is out of the root, it will be 5. 169 after taking it is out of the root, it will be just okay 13. Next again you multiply cos inverse of 48 divided by 65 minus 5 into 3 is how much? 15 divided by 13 into 5 is 65. 65 and 65 it is common with the denominator terms. Okay, so after taking it is outside, 48 minus 15 it will be 33. So that respective entire term after simplifying at the last you will be getting cos inverse of 33 divided by 65. So you people have got the result, that is RHS. Again in this question, prove that cos inverse 12 by 13 plus sin inverse 3 by 5 equal to sin inverse of 56 divided by 65. Okay, now you consider just for timing cos inverse 12 by 13 equal to theta. Okay, next cos theta equal to 12 by 13. Next draw right angle triangle. Cos its sides are what? Adjacent side divided by hypotenuse. You find out opposite side. So opposite side it will be 5. Okay, now sin theta equal to 5 by 13. Next theta equal to it is sin inverse of 5 divided by 13. So cos inverse 12 by 13 can be written as now okay sin inverse of 5 by 13. So this is equal to, next left hand side you consider cos inverse 12 by 13 plus sin inverse 3 by 5 is equal to cos inverse 12 by 13. We have simplified already and we have written as cos inverse 12 by 13 can be sin inverse of 5 divided by 13 plus sin inverse 3 by 5 is written as it is using the formula sin inverse x plus sin inverse y equal to sin inverse of x into square root of 1 minus y square plus y into square root of 1 minus x square. It is one of the standard property in the inverse trigonometric concept. Okay, now x in the sense 5 by 13, y in the sense it is 3 by 5. Okay, now with the continuation of left hand side term, sin inverse it is 5 by 13 into root of 1 minus it is 9 by 25. 9 in the sense what? 3 square 9, 5 square 25 plus okay y in the sense 3 by 5 root of 1 minus it is 5 square 25, 13 square 169. So this is equal to sin inverse of it is, after simplifying the term okay you will be getting 4 by 13 plus 36 divided by 65. See 5 by 13, 25 ones are 25 minus 9 in the sense it is 16 divided by 25. 16 in the sense it is 4, 4 divided by it is 5. 5 and 5 both are cancelled from numerator as well as denominator side. So you people have got in the first term result is 4 divided by 13 plus similarly after simplifying the second term okay that is 3 by 5 you keep as it is. Okay, find the LCM from the square root. 1 into 169 in the sense 169 minus 25 it will be 144. 144 divided by 169 it will be just 12 divided by 13. Okay, so after simplifying 12 into 3 is how much? 36. Next 13 into 5 is 65. Again you find the LCM of this full term. So sin inverse of 56 divided by 65 you will be getting. Okay, next this is the result of RHS.